For which of the following probability distribution three measures of central tendency, that is mean, median and mode, coincide? Option A, binomial distribution. Option B, Poisson distribution. Option C, normal distribution. Option D, none of these. For normal distribution, the three measures of central tendency, that is mean, median and mode, coincide. Here correct option is option C. Following is true. Here four properties of first order logic are given. First property is for all there exists x, p of x implies q of x is equivalent to, for all x p of x implies there exists s q of x. And the second one is there exists x p of x union q of x, p of x or q of x is equivalent to there exists x p of x or there exists x q of x. Third one is for all x p of x and q of x is equivalent to for all x p of x and for all x q of x. And the fourth statement is for all there exists x p of x and q of x is implies there exists x p of x and there exists x q of x. So here these are all the four properties of first order logic and all the given properties are true. So here correct option is option D. The complete graph K6 contains how many different Hamiltonian circuits? Option A 6, option B 720, option C 120 and option D 60. Hamiltonian circuit or Hamiltonian cycle is a cycle in an undirected graph which visits each vertex exactly once and also returns to the starting vertex. We have to find number of Hamiltonian circuits in complete graph K6. For this we have a formula. Number of Hamiltonian circuits in complete graph Kn is number of Hamiltonian circuits in Kn is equal to n minus 1 factorial by 2. Here K6 contains 6 minus 1, 5 factorial by 2. 5 factorial is 120 and 120 by 2 is 60. So here correct option is option. Here correct option is option D. Consider the adjacency matrix of an undirected graph G as how many chromatic partitions are possible for the graph G. Here adjacency matrix of an undirected graph is given and the question is we have to find the chromatic partitions, number of chromatic partitions which are possible for the given graph. In order to solve this problem, first of all we need to know what is a chromatic partition of the graph. Chromatic partition of a graph is nothing but partitioning all vertices of graph G into smallest number of disjoint independent sets. Disjoint independent set. So let us write the definition of chromatic partitioning. Chromatic partitioning of the graph is partitioning all vertices of the graph of G into smallest number of disjoint independent sets. This is definition of chromatic partitioning. What is independent set? Independent set. It is a set set of vertices, it is a set of vertices of the graph such that no two of the set are adjacent, such that no two vertices of set are adjacent. This is the definition for independent set. And chromatic partition is nothing but the number of partitioning all vertices of graph G into smallest number of disjoint independent sets. So if we see the graph adjacency matrix, we can say that V1 is adjacent to all the remaining vertices. V1 is adjacent to V2, V3 and V4 and V5. So we cannot group V1 in any other independent set. So V1 is single independent set. If we see V2 is adjacent to V3 and V5, and V2 is not adjacent to V4. So we can partition V4 and V2 and V4 into independent set. Why? Because these two are not adjacent, and V3, V5 are also not adjacent. So this is the smallest number of disjoint independent set covering all the vertices of the graph. So this is the only chromatic partitioning possible. So here answer is option A. There exists only one chromatic partition for the given graph.